Back at it for 6.6 part 2, composition of functions. Now, when I'm talking about composition of functions, this can be confusing. But a lot of times I will say one is inside of the other. So when you have an open circle like this, that means composition. That's saying my function of f goes inside my function of g. So it's that whole equation. So another way to look at it is like this. This whole equation goes in place of my function of f. There's two ways that you can do this. So first, if I were just to look at this part right here, if I have an x value, that means I have to actually solve for x. So I'm going to rewrite this so it looks like this. Okay? Now all this is saying is evaluate the function of f at -3. So if I just look at that inside first, evaluate my function of f at -3. So this is saying x is equal to -3. Here's my function of f. So plug -3 into that equation, and I would get -8 out. This right here is equal to -8. So that will be equal to that. So I can rewrite this now. I'm going to replace this function of at -3 with the -8 because we know that those two are equal to each other. So now I can look at my function of g and plug in my function, or plug in -8 because this is equal to -8. If I look at my function of g, it's -8 squared. -8 squared is 64. This is my only answer. That is it. It's not this one. We use this to help me find my answer. I want you to try to do B right now by yourself. Pause and try to do it by yourself. So when I'm looking at this, it's saying evaluate the -3 first in my function of g. So first, evaluate, that became 9. So now what I'm looking at is my function of f at 9. Because we're replacing that with the 9. Now when I plug that in, I get 4. So my overall answer is just 4. So what if you have not a number? So if I rewrite this, this is saying my function g is my function of f, and whenever there is an x, I'm going to replace with a. My variable should be a. So first I look at my function of f. My function of f is x minus 5, but saying we don't want x, we want a. So this will be equal to a minus 5. Now I can look at my function of g and plug in a minus 5. So whenever I look at my function of g, I'm going to replace that whole x. So here's my function of g. So it's just looking at just the x value. So if I look at just the x value, that x is being squared. So now when I evaluate at a value, it's saying, or 8 minus 5, sorry, this a minus 5, it's that whole thing is going to be replaced by a minus 5. And that right there is going to be my final answer. Now you can also factor this out or FOIL it out, but I think I can leave it just like that. So what if I have the function of f composition with the function of g evaluated x minus 2? So first I look at my function of g. So again, my function of g is x squared. So this is saying this whole thing gets replaced by my x. So if I just plug in x minus 2 into my function, it's x squared. So now this is being replaced by my x. So now this goes into my function of f. So now I'm going to have this x minus 2 squared goes into my function of f. Here, looking back at my function of f, is x minus 5. So I have, here's my x minus 5. So when replaced with my x is this whole x minus 2 squared. Right now there's no multiplying to that problem, so it would just be x minus 2 squared minus 5. Again, you can FOIL this out. I'll have to check to see, but right now we'll just keep it like this. You could FOIL and then combine your -5. So now if I look at my function of g with my function of g of 4, so it's going to be looking at this. There's two ways that you can solve this. You can find your function of g at 4. So my function of g is x squared. So that'd be 4 squared. That is equal to 16. Now this part is equal to 16, so I can replace that with 16. And 16 then would become squared because you're replacing it back into that function of g. So 16 squared is equal to 256. Would be my final answer. And function of f inside the function of f. So you're evaluating. Another way that you could think about this is if I were to write out the function of f twice. So one of the boxes is the whole thing. This whole function of f has to go inside of just one of the x's. So I'm going to replace this box with this large box. So it's saying x minus 5, that's that box, minus 5. And then I can combine my like terms. So the composition of function of f would be x minus 10, and that would be my final answer. So right now I want you to try to do the next 4 questions by yourself. Try best of your ability. So I'm looking at my first one, the composition of j, so it's the function of h inside the function of j. So this whole thing gets replaced with the x value. So if I replace this whole thing with my x value, it's this plus 1. Okay? But now what if I have this same equation, but now I'm going to evaluate -1? There's 2 ways you could do this. Since we already have this equation, we could plug just the -1 into this equation because we already found the composition. Or we can plug it in to, first plug it into your function of h. So if you first plug it into this, so -1 squared is 1, divided by 2 is 1/2. And then take that 1/2 and plug it into this equation. Either way, you should get 1.5 out. What about C? So now instead of doing function j of h, we're taking function h of j. So the whole function of j inside the function of h. Okay, look at the whole function of j. The whole function of j is x plus 1. Now we're plugging it into the box because j or h had x, so this was my x squared. We're plugging in the function of j here. So now my x squared divided by 2. So again, you can FOIL it out. Now the same thing, now instead of x, we're going to replace it with this x minus 4. So this is what we have going on here. This is where we plug in first my x minus 4 into my function of j. Remember, this is my function of j. So x minus 4 here, plus 1. So that was this part right here. And then that whole thing gets plugged into my function of h. My function of h was x squared divided by 2. So if I were to simplify this out, this becomes x minus 3 squared. And if I were to FOIL, there we have it. Now this section has a lot of word problems. Word to your mother. Okay, so the store is offering a 15% discount on all items. All employees get a 20% discount. Write a composition of functions for the following. So first thing I'm going to do is I'm going to write out 2 different equations. So if I'm going to have a discount, try to think of a discount. So we're going to label this one the store of X. So that's a 15% discount. So 15% discount means that you're actually paying 85% of it. So 15%. So you're taking 1, take away 15. So you're paying the 85%. The employee discount is 20%. So that's E for employee discount. So of X. And again, if you have a 20% discount, that means you're paying for 80% of it. To model the 15% discount and then the 20%. So first doing the 15%. So this is the same composition of doing the store discount and then the employee discount. So I'm taking this whole function of S, so 0.85x, and plugging it into my function of E right here. So now this would be equal to 0.8. Now instead of writing x, I write 0.85x. And I simplify. 0.8 times 0.85 is 0.68x. So this is my composition of, this is another way that you could look at it, the employee discount of the store discount. How to model the 20% discount and then the 15. So this would be saying take the employee discount off first and then the store discount. So here's my employee discount, so 0.8x. Now you plug that into your store discount, the 0.85. So that would be 0.885, 0.8x, and I still am going to get 0.68x. This is my store discount after my employee discount. If you were an employee, which discount would you prefer to take off first? Well, if you were an employee, it doesn't matter. If you look at things, these equations are the exact same. So it doesn't matter the order in which you take off first. So doesn't matter. Live your life to the fullest. However, you have a coupon for a $5 off any large pizza. You also get 10% discount on any pizza if you show your student ID. How much more would you pay for the large pizza if the cashier applies the coupon first? Write and solve the problem using composition of functions. So here I have off. So if I'm going to take a $5 off the coupon, so my coupon code would say, here's my large pizza, and I get $5 off. However, I also get a discount for my student ID. So I'm going to put D of X. And I get, again, if you get 10% discount, that means you're paying for 90% of the value. So we have two compositions of functions. Coupon, discount, and we have discount, coupon. You want to see which one will be what. So this is saying put their whole coupon, function of D, inside my function of C. So it's this whole thing goes inside my x, 0.9x minus 5. This is saying put the coupon. So put the coupon, this whole thing, inside my x for my discount. So this is going to be 0.9x minus 5. I have to simplify that one. So I have 0.9 times x, and then minus 4.5. So now when you're comparing these, if you take the discount and then the coupon, you get $5 off. But if you take the coupon and then the discount, you get $4.50 off. So this would be a better deal. So how much more would you pay for the large pizza if you apply the coupon first? So this was the coupon first, and then the discount, you pay 50 cents more. Which may not be that big of a deal, but money adds up. More money, it adds up. And there you have it, composition of functions of 6.6. You have a great day.